In this video, we're going to look at polynomial long division. And we're going to look at the quotient and the remainder of the solution and the difference between the two. The first example, we have 3x squared plus 5x plus 6 divided by x plus 1. And so I'm going to rewrite this just like we used to write long division when we first learned it, as x plus 1 and then our division bar and 3x squared plus 5x plus 6. And now, the first thing I'm going to do is ask myself, what times x gives me 3x squared? And 3x times x is 3x squared. So I have 3x times x is 3x squared, and 3x times 1 is 3x. And now I'm going to subtract down. So I have 3x squared minus 3x squared is 0. 5x minus 3x is 2x. And I'm going to carry down my 6. And now, what times x gives me 2x? 2. So plus 2. 2 times x is 2x. And 2 times 1 is 2. And again, we're going to subtract. So we have 2x minus 2x is 0. 6 minus 2 is 4. So here we could say that the quotient is 3x plus 2 and the remainder is 4. Now it's important, if we go back to the original question, the way it's written, 3x squared plus 5x plus 6 divided by x plus 1, when we write equals, we have to be sure to write the quotient and the remainder. We can't just say 3x plus 2, because that's just the quotient part. We have to write plus 4 over x plus 1. In this next example, we have x cubed minus 1 divided by x minus 1. And in this example, it's important to remember to have placeholders for the missing degrees of x. So here we're going to have x cubed, and what I like to do is just write plus 0x squared plus 0x minus 1. You don't have to put the 0x squared plus 0x. You could just leave space so that everything lines up, but I like to write it in there just so I can see the place being held. And now, what times x gives me x cubed? X squared. X squared times x is x cubed minus x squared from x squared times negative 1. And now we're going to subtract this. So we have x cubed minus x cubed is 0. 0x squared minus negative x squared is positive x squared. And now I'm going to bring down my 0x. And now, what times x gives me x squared? So that's x. So plus x. X times x is x squared. X times negative 1 is negative x. And now we're going to subtract it. So we have x squared minus x squared is 0. X minus a negative x is positive x. And I'm going to bring down my negative 1. And positive 1 times x gives me x. And 1 times negative 1 is negative 1. We're going to subtract that, and that gives us 0. So here our quotient is x squared plus x plus 1, and our remainder is 0. So we could say that x cubed minus 1 divided by x minus 1 is equal to x squared plus x plus 1. And for anybody that remembered their perfect cubes going into this problem, you may have already known that. But the biggest reason I wanted to show this example was to show the placeholders in the long division for when there's problems that aren't perfect cubes that you need to be able to work through the long division. In the last example, we have 3y minus y squared plus 2y cubed minus 1 divided by y plus 2. So this one, when I write it, I'm going to write the degrees in descending order to make it easiest on myself. So 2y cubed minus y squared plus 3y minus 1. And now I'm going to have 2y squared times y is 2y cubed plus 4y squared and subtract. And 2y cubed minus 2y cubed is 0. Negative y squared minus 4y squared is negative 5y squared. And now I'm going to bring down my 3y. And then we have minus 5y next, because negative 5y times y is negative 5y squared. And negative 5y times 2 is negative 10y. And now subtract. So we have negative 5y squared minus a negative 5y squared is 0. 3y minus a negative 10y is 13y. And now I'm going to carry down my negative 1. And then I have plus 13. 13 times y is 13y. 13 times 2 is 26. So now we subtract it, and we have 13y minus 13y is 0. Negative 1 minus 26 is negative 27. So we have a quotient of 2y squared minus 5y plus 13 and a remainder of negative 27. So we can write the answer as 2y squared minus 5y plus 13 minus 27 over y plus 2. Or you could write it as plus and then put a negative 27 in the numerator if you want to do it that way. And that's all for this video on polynomial long division.